Welcome back to the STEMverse. If you've ever looked at an integral and thought, how am I supposed to do that? Then this episode is for you. Today we're diving into the basic rules of integration, the tools you'll use over and over again to tackle integrals with confidence. And don't worry, we'll keep it simple, visual, and straight to the point. In episode 1, we introduced integrals as the reverse of derivatives. And we said integrals help us calculate things like area under curves or accumulated quantities. Now it's time to actually solve some integrals using basic rules, starting with the easiest one of all. So we're going to start with the power rule. And say you're trying to integrate x squared. You would add 1 to the exponent and divide by the new exponent. And that's the power rule. So anytime you have a function and it's just x to the power of something, or a constant, then x to the power of something, then it'll always be the power rule. So you just add 1 to the exponent and divide by the new exponent. And then don't forget plus c. Plus c matters. It's very important. And yeah, so if you want to try an example, here's an easy one that you can try all by yourself, and you can see if you got it. So you can try x to the 4 d of x. It's a good practice. And now we're going to move on to the sum rule. So we're going to do an example of an integral of x squared plus 3x d of x. So this one's really simple. All you have to do is separate. So if something's just a sum, 2 components, then you just separate them. So integral of x squared plus the integral of 3x. Don't forget your d of x. And you'll just take the integral of those. So again, power rule. It'll be x cubed over 3, and then plus 3x squared over 2. And then don't forget your plus c. So that is the sum rule. So you can just break complicated expressions into manageable parts. And we're going to use the constant multiple rule. So for example, if you had 5x d of x, then you could just pull the constant out. So it would become the integral 5 times the integral of x d of x. So then you would just take the integral of x. So it would be 5 times x squared over 2 plus c. And that would be your answer for that one. Now, some basic integrals that you should memorize are this one here. So x to the power of n d of x is equal to 1 over n plus 1 multiplied by x to the n plus 1 plus c. So this is what we just learned, the power rule. Add 1 to the exponent, divide by the new exponent. And another integral that you should memorize is the integral of e to the power of x, d of x. So e to the x, its integral is still just e to the x plus c. Because when you take a derivative of e to the x, it is still just e to the x. So the integral is the same thing, just e to the x. So if you had 1 over x, d of x, the antiderivative for this would be ln of x plus c. But be careful, because when the power of x to the n, so when n in this case is -1, that's an exception to this rule. Be careful with that. Now another very important one to know is the integral of cosine of x, d of x. That one is sine of x plus c. That one's very important to know. And the integral of sine of x, d of x, is negative cosine plus c. Negative cosine of x plus c. And that's because it's just the opposite. We're thinking backwards from the derivative. So the derivative of sine of x is cosine. So if we have cosine, then it would make sine. So that's why we have cosine of x makes the antiderivative sine of x, and sine of x makes the antiderivative negative cosine of x. And those are some important integrals to know and keep in mind. Now we're going to try an easy example together just to make sure you guys have the hang of this. So 3x, the integral of 3x squared minus 2x plus 1 d of x. So here the first thing we would do would be to separate. There you go. So I'm going to change the color here. There you go. So we would separate it using the sum rule. So we do an integral of 3x squared plus the integral of, we could actually take out the negative sign and make it negative integral of 2x plus the integral of 1. And don't forget our d of x. Now we're going to take the integrals of each of these and evaluate them. So it'll be 3x squared would be 3x to the 3 over 3 minus 2x to the power of 2 over 2 plus x plus c. And that would be the answer to this integral. Now, if you want to try an example on your own, I'll put a little example on the screen so you can practice a little bit and see if you get the right answer. I'm not sure why it's not showing very well on the screen, but here it is. It's the integral of 4 over x d of x. So you can try that one out and see if you've got it. But I'll give you the answer. You can see if you got the answer. So it would be 4 ln of x plus c. So let me know if you got that answer. I hope you did. So to sum it up, use the power rule unless n is -1. Break up sums and pull out constants. Memorize the common integrals that you'll need to know. And always add plus c when it's an indefinite integral, not for definite integrals. These are the basics that make integration manageable. Now, if you want to practice these rules, I've got you covered. Download the free worksheet for episode 2 in the description below, and practice will help. It really helps. Make sure you practice. So thank you for watching. If you found this helpful, hit like, subscribe, and tap that bell so you don't miss episode 3. And we're going to be tackling U substitution, aka reverse chain rule, in episode 3. So make sure you watch that too. Drop a comment if you have questions or requests for future episodes. This is the STEMverse Academy, where we make STEM make sense. See you next time. Bye.